Alright, today we're going to talk about the properties of water and the things that help make it such a unique molecule. And a molecule is where two or more different atoms have combined to form a compound. And in this case, the compound is made of H, which is hydrogen, O, which is oxygen, and it takes two hydrogens for every one oxygen to make a water molecule. And because of the way this molecule forms, it gives water a lot of unique properties. And one of the properties of water is buoyancy. And we already mentioned this when we were talking about density, but it is that upward force that pushes, water pushes on an object, and it keeps something afloat. And if sometimes an object's buoyancy is not greater than its weight, and it sinks. And so that is buoyancy. So a boat floating in water would be an example of buoyancy. A buoy that, or a channel marker that you see out in the sound would be an example of buoyancy. You can also just draw a picture of a boat here with water pushing up on it and the boat floating for your picture. Polarity is about the structure of the water molecule, and polarity is what gives water its uniqueness. The hydrogen atoms have a slight positive attraction, and the oxygen has a negative attraction, and that attraction between the positive and the negative is what gives water its uniqueness. The oxygen molecule is a larger molecule than the hydrogen, so the negative pull is a little bit stronger than the positive pull. And so water is still attracted to other molecules as it comes in contact with things. So that attraction, that extra buzz of negative attracts it to other things. So my upside down Mickey Mouse ears represent a water molecule, and we are going to, you can use this as your diagram, and we want to add in what is the water, its parts, and where the attraction is. So so as you draw your upside down Mickey Mouse ears for polarity, there are two H's, and they are both positive. So they're going to go in the ears, and then oxygen is negative, and oxygen has two electrons to each one positive proton of hydrogen. So there's attraction here, there's attraction here, and the oxygen molecule being larger, there's still some attraction left over to attract other molecules. So if you'll draw your Mickey Mouse ears to represent your polarity. And I would just say my example is all of water's unique properties. Now you'll notice there's some video clips in the presentation. We're going to watch all the video clips at the end, and then you can, and you might can add some more examples or get some more ideas for your diagrams when we do that. Alright, now the next two properties, the first one is surface tension, and because water's molecules are attracted together, it's often called a sticky molecule, and they are sticking together, and they bead together at the surface. And at the beginning of class I started with an example of surface tension when I had the cup of water, and I asked you to estimate how many pennies you thought I could drop into it. And we got a lot more pennies than most of you predicted because I turned the penny sideways and had a very slim surface area, and they broke the surface very gently like a great diver instead of a belly flop. And we got a lot more pennies in there because the surface, the stickiness, it sealed right back up. And that would be an example of surface tension. In a few minutes, we're going to watch a video where you're going to see the Jesus Christ lizard appear to walk on water because of the aerodynamic design of his feet, and surface tension of the water allows him to look like he is running across the surface. The water strider is an insect that also appears to walk on water. Now, we've already talked about density and that it's a ratio, and water has a density of 1 gram per cubic centimeter. So many substances are compared to water's density, whether they will sink or float or subsurface. And so you can use any examples you can think of something sinking and floating here on your notes. Now, this is a picture. Obviously, it's been edited slightly in Photoshop, but this backstroker is barely breaking the surface because of his aerodynamic body shape and swimming motion. So you can see the water kind of beating and bubbling around him, and he is sticking to him, which is adhesion, and then barely breaking the surface, which increases his speed, which would be surface tension. Now, adhesion is the property of water to stick to other substances. And I'm sure many of you have in the summer had a sweating glass or sweating container, and you pick it up and whatever was underneath it stuck to it, whether it was paper or a stone coaster or a vinyl coaster, and then when you pick it up, that gravity will literally pull that object down and it'll drop. And that is water's ability to stick to other substances. So when you remember when we did the penny, we were talking about independent and dependent variables, and you were able to pile the drops on top of the penny. That property is adhesion. Capillary action is very important for photosynthesis in plants because that allows water to absorb into the soil. Gravity pulls it down. It infiltrates, if you remember our water cycle notes. And then capillary action allows the roots to pull it up and go against gravity and get the water up to the stem and the leaves of the plant. Cohesion is water sticking to itself. So for surface tension to occur, it is because of the cohesive properties of water molecules, that they are sticking to themselves. And so as those water drops pile up on top of that penny and the pile gets higher and higher, that is cohesion. The first layer of water drops sticking to the penny is adhesion, and then water upon water upon water and getting that big giant drop is cohesion. Raindrops are also another example of cohesion. In a cloud, the tiny individual molecules of water stick together. They are cohesive, they coalesce, and they form larger drops that fall to the earth. Water is also called the universal solvent because of this attractiveness and this little extra buzz of negative. Water is attracted to many other substances and it will dissolve them. So when you make coffee and tea and Kool-Aid and your juices and anything that will dissolve in water, that would be why water is called the universal solvent. It dissolves many other substances than any other substance. And then the last property is specific heat. Water is very slow to heat up and very slow to cool down compared to, say, metals. For example, if you think about putting a pot on the stove and putting water in it and bringing it to the boil, the pot itself will get hot enough to burn you, and the water inside will still be cool and not burn you. So water itself is slower to add heat. And it's also slower to cool down, which is why you can go to the beach in November and the air may be very cold and cool and you not want to get in the water, but the water itself has not lost its summer heat yet. It is slower to cool down. It's also why you can go to the beach in the summer and you can run from your towel to the ocean and your feet will burn on the sand, but you step in the water and then you grab yourself because the water is still cool. It has not got its summer warm up yet. It is still at lower temperatures from the winter, and it is slower to warm up than the sand. So they have different specific heats. And that's where we're going to stop for today, and we've got some video clips we're going to watch to give you some further examples, and then you're going to do some little lab activities to help you get some more ideas for your sentences that you're going to do for homework tonight.